Good morning. I welcome you all to the series of lectures on thermodynamics. Today we are going to discuss about the heat and different points of heat and the sign convention. See, let us see the definition for heat. Energy transfer between the system and surrounding through the boundary due to temperature difference is called heat. For example, let us consider a simple example. This is the system. It is having a heat inside. You know, it is having high temperature than surrounding. Then heat transfer takes place from inside to outside through the boundary, and it is exposed to surrounding. And heat transfer takes place from system to the surrounding. So that's what we written here. Energy transfer between system and surrounding through the boundary due to temperature difference is called heat. Because of temperature difference, energy transfer through the boundary only, through the boundary, that is called heat. Next, it is a form of energy in transient. See, it is a form of energy, already we discussed, in transient. In transient, it appears at the boundary of the system. It appears at the boundary only. It appears only at the boundary. Like work energy, heat is a boundary phenomena. See, it appears at the boundary, so it is a boundary phenomena. Like work is also boundary phenomena. Both heat and work are boundary phenomena. Heat is not a property of the system. See, we will discuss this point later. It is not a property of the system because it does not depends on endpoints. For example, if I draw a thermodynamic process, for example, this x y coordinate, it is heat is transferring from this point, that means high temperature body, that is system, to surrounding. If I represent this process on pv coordinate, some xy coordinate, the graph is something like this. For example, then amount of heat transfer is not depend upon the path followed by the, it is not depend upon the endpoints. It depends only on the path followed by the system. It is a path function, it is not a point function. So if it is not a point function, it is not a property of the system. Next, amount of heat transfer between system and surrounding depends on path followed by the system, right? See, amount of heat transfer takes place between the system and surrounding is depends only on the path followed by the system, not depends upon the points, not depends on end points. So hence it is a path function. It is a path function because it is followed by path. Amount of heat transfer depends on path followed by the system. So it is a path function. It is inexact differential. See, if it is a point function, exactly differentiable. It is path function, so inexact differential, and it is represented as Q122. It is represented as heat transfer in process 1 to 2 as Q122. It is depends only on path function, path followed by the system. So it is a path function, and it is not a property of the system. And let us go for the sign convention. See, sign convention, heat is entering, we consider as positive. Next, heat is rejecting, heat is leaving, we consider as negative. The reverse is work. If work is entering, that is work done on system, negative. If work is done by the system, it is positive. Okay, thank you very much.